Use the table of values to find the limit, if it exists. If it does not, enter D and E. So the value of a limit, we see what's happening as we approach a specific value from the left or right for x's. So for instance, here, all of my x values, as we go from 8 to 8.2 to 8.8, 8.9, 8.99, 8. We're getting closer and closer to the value 9. And as I approach 9, and if you'll notice, all of these values are less than 9. So if 9 is right here, then this could be 8, 8.2, 8.8, 8.9, 8.99, and so forth. So we're approaching 9 from the left, so from the values that are smaller. And what's happening to the graph itself, so whatever this function looks like, as we approach, the graph is getting closer and closer to a specific number. So as we approach this from the left-hand side, this graph is approaching the value going 14, 14.5, 14.9, and so forth. We're getting closer and closer to the value 15 on the y-axis. And I guess I shouldn't have jumped to such a smooth graph by default. But right here, this is what's happening. So our graph is approaching 15 on the right-hand side. Or sorry, 15 on the y. Now, as I go from the right, now they've kind of rearranged the direction of things, but that's okay. Notice here, oh, no, they haven't, I'm sorry. They just started at 10. All right, so starting from 10, so we go from 10 over here to like 9.6. Oh, and I probably misscaled that, but that's okay. And then 9.2, 9.1, and then 9.01, and so forth. So we're getting closer and closer to the value 9. So we're approaching 9 again. But the question is, what's happening on the y? So the y values, we start at 16.8 and we're decreasing down to 16. So what's happening here is the y values on this side are not approaching the same number as they were on the left. So if the limit from the left and the limit from the right do not agree, what we say is this limit does not exist. So when we give our answer, we just say this one does not exist.